Alright guys, I hope everybody's doing okay. What we've got here is a proof of concept that by increasing the number of samples we could actually get a better estimate of population mean. So what we've got here in column O is a data set, and these are in fact BMI values for 67 uh, people, right? So we could always select our column and see what is the count. It turns out to be 66. Okay, so we've got 66 BMI values, and what we want to do in the first experiment is just sample two values randomly from these 66 values. So one simple example of a sampling could be to just click on one cell, hold the command key if you're using a Mac, or the control key if you're using Windows, and click another cell, and that way you get these two cells selected. You can then do a control C or a command C to copy them and simply paste them here with a control V or a command V, depending on if you're using a Windows or a Mac. So you just paste them right there and you hit enter, right? So you get these two values here. So I've just sampled the two values from the data set and put them in my first pick column. The same way I could do for the second, third, fourth, fifth, and all the way to the 11th pick right here. Once I've done that, what I would do next is calculate the average of these two values that I've picked, and I would store them in this specific cell right here. And I can always drag this all the way to the right hand side to calculate the average for all of these columns and place it right here. Now once I have all of these averages, I can always compute a mean average, which is essentially then an average of these means right here. Okay, so I have the mean for each column, and then I could just compute an average of these, right? So which is why it says P12 to Z12. This is the column P, 12th row. This is the column Z, 12th row. So P12 to Z12, I could simply compute an average of these means, and that gives me one value, 23.92. What I also have is the population mean. Remember, I have access to the entire population. I could just select it and notice that I have an average here, 23.2. And if you look at it from two decimal places, that is 23.17. I could always use a formula to calculate this, as I have done for the column O. So I have these two averages, and here I simply compute their difference, right? I use a minus sign in the formula bar to find the difference between the two, and that turns out to be negative 0.75. What's interesting is if instead of having two samples for each pick, if we go ahead and have, say, 10 samples for each pick, and then compute the mean and end up with the mean of means, such as this here in this column, and then compare that to the population mean, we end up with a lower error between these two values, right? So this is an interesting idea that, and and look, we could always have different metrics like a squared error or an absolute error. In fact, let's just call it an absolute error. I will type in ABS for absolute, and that is going to make the negative error as a positive. It does not affect the value, it just converts the sign. If it's a negative sign, it makes it positive. So now notice the difference between the two. We're talking about these two specific values. 0.75 is the absolute error. When we perform the experiment with only two samples for each pick, and 0.02 is the error when we get 10 samples for each pick. The number of picks are the same. We have 11 picks, but the samples in each pick has increased on the left hand side, and that averages out the difference or any variation, and that gives us a better estimate of the population mean, which is why we have the reduced error, as we can see on the left hand side, for when we have more number of samples for each